Hello everyone and welcome to our first intro lesson regarding logs. So we're going to watch this video, we're going to take some notes and get ready to start graphing logs or logarithms. All right, so the first thing we're going to do is turn to homework 7-0. That is going to be our first homework of the next unit. And notice it says example 1, given below is the table in the graph of the equation y equals 2 to the x. Notice 2 to the x is an exponential function. We just came out of the exponential unit. And also know that because 2 is greater than 1, it's exponential growth. So we have this original table of values here, and we have the points graphed right here. I'm going to kind of just go over it in red here. This is the exponential function. Now we're going to find the inverse of the points. So if you remember, the inverse is the reflection in the line y equals x. That's that very special line where every y equals every x coordinate. And I'm highlighting this line here in green, y equals x. Now you may have remembered that to get the reflection in the line y equals x, you just switch the x and y coordinates. So this means that x comma y is going to become y comma x. Okay, so let's go down here and we're going to switch our coordinate pairs. So it's going to be 1/8 comma -3, 1/4 comma -2, 1/2 comma -1, 1 0, 2 1, 4 2, and 8 3. Now I'm going to graph my inverse, and notice the inverse is notated with the f to the -1, and f to the -1 means inverse. I'm going to graph my inverse over this line, y equals x, okay? So let's do some of the easier ones. 0 1 becomes 1 0. 1 2 becomes 2 1. 4 2, I'm just doing a little scale here for you guys. 2 4 becomes 4 2. Okay. -1 1/2 becomes 1/2 -1, etc. Okay. So you get the idea. 3 8 becomes 8 3. And then we're going to connect the dots, and please note that there are arrows on the graph for the original function, which is y equals 2 to the x. So we're going to put arrows on the graph for the inverse, and that indicates that it goes on forever. It's an unrestricted domain. All right, so this equation is going to be the log function, and specifically the equation is going to have the same base. So it's going to be y equals log, and now the base is going to be a little subscript. So it was base 2 for the original, so it's going to be base 2 for the inverse. So we have y equals log base 2 to the x. Okay, so we call this little thing a base, base 2. So now going down below, we see it says log functions and exponential functions are inverses of each other. Okay, that's a great, very important relationship. And remember to find the inverse of a function. So first of all, for the points, x comma y, we said we switch them and it becomes y comma x. And remember we said that's a reflection in the line y equals x. Little r means reflection in the line y equals x. Or remember when we do it algebraically, we do switch x and y, solve for y. And we're going to talk about how to do this algebraically this week. All right, so that's that. So now because we know that they're inverses, it turns out that everything about them is going to switch, because if x and y switch, basically everything else is going to switch as well. Okay, so for the exponential graph, which remember if you look above was this one, this y equals 2 to the x here, the domain was all real numbers, or -infinity to infinity, and the range was actually 0 to infinity, because there was an asymptote, a horizontal asymptote, at y equals 0 for the x-axis. So when we do the inverse, basically the domain and the range are going to switch. So if the domain was all reals, now the range is going to be all reals. And if the range was greater than 0, now the domain becomes greater than 0 because the asymptote's going to switch as well. What you may notice is that on my inverse, the asymptote now becomes over here. It's a vertical asymptote on the y-axis, okay? So I'm going to write all that information now down below. Okay, so the original I'll write in red and the inverse in blue. So the domain was all real numbers of the original. That becomes the range of the inverse. Again, you can write negative infinity to infinity, or you can write all real numbers. The range of the original was y is greater than 0, or 0 to infinity. That becomes the domain of the inverse. X is greater than 0, or 0 to infinity. The asymptote of the original was the x-axis, which was y equals 0. That becomes the asymptote, that becomes the x-axis. The x-axis becomes the y-axis of the inverse, and that is x equals 0. So the asymptote switches from a horizontal asymptote for the exponential to a vertical asymptote for the inverse. Now the quadrants that it lies in, the original lies here and here in quadrants 1 and 2. And then the inverse lies in here, quadrant 1 and quadrant 4. Okay, so 1 and 2 versus 1 and 4. So let's put that in. 1 and 2 versus 1 and 4. Now we go to intercepts, okay? Now remember, if there's an asymptote, there's not an intercept for that thing. So the exponential has a y-intercept of 0, 1, which is right here. And then it has no x-intercept. And then when it's switched, the 0, 1 becomes 1, 0. That becomes the x-intercept of the log. So the y-intercept of the original becomes the x-intercept of the log, and the log has no y-intercept because it has an asymptote, okay? So the original function, the exponential, has a y-intercept of 0, 1. This becomes an x-intercept of 1, 0. It had no x-intercept because there was an asymptote present on the x-axis. Now there is no y-intercept because there's an asymptote present, okay? So that is some of the basics of the foundational stuff that we need to know about the graphs, and sometimes these are going to be asked in the form of multiple choices, where they'll say which of the following is true, and they'll give you some choices, or which of the following are not true, etc. And you have to know the domain, the range, the asymptotes, where is it increasing, where is it decreasing, etc. Both of these are always increasing, by the way, because from left to right, they're both going up. That's because the original was exponential growth. Now, let's go to another example. Look at example 2. So now we have a different base, okay? This is going to be called base E. You guys know base E because we did it in the last unit. So this is still exponential growth because it is growing, because remember E is really about 2.718, which is an irrational number. So here's my original graph, y equals e to the x. All right, now here's my original graph table, and these are the coordinates. So now it says sketch the inverse f negative 1 of x on the same axes as f of x. So what we're going to do is we're going to switch x and y. Just like we said, that's going to be a reflection in the line y equals x. So let's make our equation, let's make our dotted line for the line y equals x, because that's going to be our line of symmetry here. And now what we're going to do is create a new table of values for the inverse. I'm going to label this inverse for now, or f negative 1. And remember, this is the original f of x, okay? So when we switch them, negative 3.05 becomes 0.05, negative 3. Negative 2.14 becomes 0.14, negative 2. Negative 1.37 becomes 0.37, negative 1, etc. 0, 1, 1, 0. 1 comma 2.718 becomes 2.781. That's really the E. And then 2 comma 7.39 becomes 7.39 comma 2. So we're going to sketch this inverse here. I'm not really going to do all these points, but we're just going to kind of eyeball it. So we know this one's 1, 0, 2.718 comma 1. Just kind of do your best here with this to get an idea of where it's going to be. And you want to try to make it around the same steepness as the original, but reflected. Okay, so now we just connect the dots. Remember, there's an asymptote hanging out here. There's an asymptote at the y-axis. Okay, so this is the inverse. We'll call it f negative 1 of x of the e to the x. Okay, what is the equation of the inverse? Well, it's got to have the same base. So we're going to do f negative 1, which means inverse. And we're going to write log base e x. So remember with 2 to the x, if you go back to the 2 to the x, the 2 to the x was the base. And the inverse was base 2 to the x. Base 2 is a little number in the bottom. So similarly here, we have a base e. And then the inverse is going to be base e. Okay, that's the base. Now, it turns out that the mathematicians decided that they think it looks a little awkward to write log base e, so they gave this a specific name. And the name that they gave log base e is called ln. ln is really log base e. So another name for log base e is ln. And there you have it. That's the graphic relationship between exponentials and logs. They are inverses, which means they are reflection over the line y equals x. Thus, all the coordinates switch.